Many times, we have had the need to use an electric float to control the water filling of a tank through a pump, and well, here I am going to explain how to make the electrical connection correctly. But first, let's look at the internal configuration of the float to understand better. The electric float consists of 3 cables. A common cable, which is usually black. A brown normally closed configuration cable, and a light blue normally open configuration cable. This device can be found in 2 possible situations: at a maximum level and at a minimum level. The distance between these 2 points will depend on how short or long the cable is from the counterweight to the head of the float, since it moves with respect to the counterweight. This way, if the float is vertically up, current will flow through the common and normally closed wires. While, if the float is in a vertical downward position, the current will flow through the common and normally open wires. Taking these conditions into account. With float in the minimum position, it must allow the electric pump to be turned on, then the black and light blue cables must be used. Since these also allow the electric pump to be disconnected when it reaches the maximum position. Now, let's look at the simplest connection that can be made using an electric float in an elevated tank. First, the minimum and maximum level at which the electric float will operate must be regulated. To do this, the distance from the counterweight to the head of the float and the height at which this counterweight must be fixed in the tank must be adjusted. The wiring should be done as follows. A cable is taken from the key or manual switch and connected to the black cable that comes with the float. From the blue or light blue cable, a cable is run to one of the power cables of the electric pump. From the other cable it is connected and brought back to the key or manual switch. It is also possible to consider a ground cable for protection on the electric pump. Remember that you must insulate the splices in the connections you made with tape or some other type of insulation, including the cables that were not used in the connection. In this way, when you raise the lever of the key or manual switch, and the float is at the minimum level, then it should allow you to turn on the electric pump to fill the tank. And if it reaches the maximum level, then it should allow the circuit to be disconnected automatically and the electric pump to be turned off. Although all this wiring and connection seems correct and works, there is actually an observation here. And the float is connected to the same circuit as the electric pump, that is, a lot of current will be circulating through them, as well as a high voltage. For example, where I live, we use a supply voltage of 220 volts between phase and neutral, and that voltage would also be present in the floats. According to the IEC standard and various regulations from different countries, they maintain that the power supply for devices operating in humid or wet locations must be no more than 24 volts. Therefore, one of the most appropriate solutions for this case is to use a contactor, which separates the maneuvering or control circuit from the power circuit. To do this, a contactor with a 24-volt coil must be used, which allows the control part to be separated from the power part. And to go down to that voltage that the contactor coil needs, a transformer with a reduction to 24 volts must be used. So, with these 2 additional components, we can now make a secure connection. For wiring the floats, which is the control part. First, it must be connected to the transformer and thus obtain a voltage of 24 volts at its output. From one of the output wires of the transformer, it is connected and led to the common black wire of the float. From the light blue cable of the float, it is connected and taken to terminal A1 of the contactor, and from terminal A2 of the contactor it is connected and taken to the remaining cable of the transformer. For this circuit, thin wire is usually used, enough to withstand the current of the coil and the voltage of 24 volts. There are other contactor models, which the arrangement of terminals or terminals is different, as shown, but it must always be taken into account that the cables that include the float must be connected to coil A1 and A2. To connect the electric pump. From the output of the thermomagnetic switch, the cables are connected to the power contacts of the contactor, and from its output to the electric pump. So that would be the whole connection. In this way we isolate the control part that corresponds to the float, with respect to the power part, which is made up of the electric pump. Thus, there is less probability of receiving an electric shock if water or moisture passes through the float or any connection. If you want to know more about connecting floats for a tank and an underground cistern, here at the end of this video and in the description I will leave the respective links. See you later.